Hello students, welcome to this lecture 1 Probability and Statistics. In this lecture, here we will discuss ncert exemplar problem 1 Probability and Statistics. Okay, so let us start. So in this section, we will discuss very short answer type questions. Okay, so in first question here we have the median of an ungrouped data and the median calculated when the same data is group are always the same. Do you think that this is a correct statement? Okay, and give reason. So no, always, because for calculating median of group data and the formula used is based on the assumption that the observation in the classes are uniformly distributed, okay, were equally spaced. Okay, so that is why the median of an ungrouped data and the median calculated when the same data is grouped are always not same. Okay, are not always the same. Okay, so the given statement, this statement is not a correct statement. Okay, so now let us move to next problem. So in next problem here we have this statement: in calculating the mean of group data grouped in classes of equal width, we may use the formula x bar. This is equal to a plus summation a by di divided by summation a I, where a is the assumed a must be one of the midpoint of the classes. Okay, and in the last statement, correct. Okay, so is the last statement is correct. So justify our answer. So let us see answer. So no, it is not necessary that assume considered as the midpoint of the class interval. Okay, so it is considered as any value which is easy to simplify it. Okay, so here this is not necessary that assume considered as a midpoint of the class interval. So the given statement, the last sentence, a must be one of the midpoints of the classes. This line is a wrong line. Okay, so this is why the last statement is not correct statement. Okay, so this is a false statement. And now let us check question number 3. So in question number 3 here we have, is it true to say that the mean, mode and median of group data will always be different? Okay, so justify your answer. So let us see the answer. So the answer is no. It is not true to say that the mean, mode and median of group data will always be different. Okay, sometimes they may be equal. So no, the value of these three measures can be no, the value of these measures can be same. Okay, depends one the type of data. Okay, so which type of data has given to us, that depends on this. Okay, that is why the the value of mean, mode and median of group data will not always be different. Okay, so this statement is a false statement. So now let us move to next problem. So in next problem here we have this statement: will the median class and modal class of group data always be different? Okay, so justify your answer. Okay, so here not always, it depends on the given data. Okay, so it is not always true, the median class and model class of group data will be always be different. Okay, will be different, that is not correct. Okay, so this is not true always. So now let us move to next problem. So in next problem here we have, in a family having 3 children, there may be no girl, 1 girl and 2 girls or 3 girls. So the probability of each is 1/4. Is this correct? Justify your answer. Okay, so let us check here. The probability of each is not 1/4. Okay, because the probability of no girl in 3 children is 0, and probability of 3 girls in 3 children is 1. Okay, so the probability of each is not always 1 by 4. Okay, so this statement, the probability of each is 1 by 4, this is not correct. Okay, so now let us move to next one. So in next one, here we have a game consists of spinning and which come to rest pointing at one of the regions 1, 2 or 3. Okay, so you can see this figure. Are the outcomes 1, 2 and 3 equally likely to occur? Okay, so give reasons. So here we can give reasons. The outcomes are not equally likely because 3 contains half part of the total region. Okay, so 3 contains half part of the total region, and 1 and 2 contains half part of the total region. Okay, so here 3 contains half part of the total region, so it is more likely than 1 and 2. Okay, so 3 can happen more likely than 1 and 2, since 1 and 2 each contains half part of the remaining part of the region. Okay, so therefore the outcomes 1, 2 and 3, they are not equally likely to occur. Okay, so now let us move to next problem. So in next problem, here we have a proof through 2 dice once and computes the product of the numbers appearing on the dice. Okay, p who throws 1 die and squares the number that appears on it, who has the better chance of getting the number 36. Okay, and why? So let us see the answer. So here approve throws 2 dice once. Okay, so total number of outcomes, this is equal to 36, and number of outcomes of getting product 36 is equal to 6 is equal to 1. Okay, that is 6 into 6. Okay, therefore probability for approve is equal to 1 by 36. Also Pu throws 1 die. Okay, and so total number of outcomes is equal to 6, and the number of outcomes for getting square 36, that is equal to 1. Okay, since 6 square is equal to 36. Okay, so number of outcomes for getting square 36 is equal to 1. Therefore probability for Pu, this is equal to also number of favorable outcomes for getting square 36 divided by total number of outcomes. Okay, and this is equal to 1 by 6. Okay, and that can be written as 6 by 36. So hence Pu has better chance of getting the number 36. Okay, Pu has greater chance than Apurv of getting the number squaring 36. Okay, so now let us move to next problem. So in next problem, here when we toss a coin, there are 2 possible outcomes, head or tail. Okay, therefore the probability of each outcome is 1 by 2. Okay, justify your answer. So yes, the probability of each outcome is 1 by 2 because head and tail are equally likely events. Okay, basically when we call toss a coin, okay, that case we take the coin as fair coin. Okay, so that is why head and tail both are equally likely events. Okay, therefore probability of each outcome is 1 by 2. Okay, that is why yes, the probability of each outcome is 1 by 2. So the given statement in question number 8 is a correct statement. Okay, now let us move to next problem. So in next problem, here we have a student says that if you throw a die, it will show up 1 or not 1. Okay, therefore the probability of getting 1 and the probability of getting not 1 is equal to 1 by 2. Is this correct? And give reasons why it is correct or not. Okay, so let us see the reasons. this is not correct. Why? Because suppose we threw a die, then total number of outcome is what? Total number of outcome is 6. Okay. Then possible outcomes, this is either 1 or 2 or 3 or 4 or 5 or 6. Okay. So therefore probability of getting 1, this is equal to 1 by 6. Okay. So probability of getting 1, this is equal to 1 by 6. And now probability of getting not 1, this is equal to 1 minus probability of getting 1. Okay, that is equal to 1 minus 1 by 6, and this is equal to 5 by 6. Okay, so probability of getting not 1, this is equal to 5 by 6, and probability of getting 1, this is equal to 1 by 6. But in this question here we have given this statement, the probability of getting 1 and the probability of not getting 1, each is equal to 1 by 2. Okay, so the given statement is not correct. Okay, the given statement is not correct. So now let us move to next problem. So in next problem, here we have, I toss three coins together. Okay, the possible outcomes are no heads, 1 head, 2 head, or 3 heads. Okay, and so I say that probability of no heads is 1 by 4. So what is wrong with this conclusion? Okay, so let us justify what is wrong with this conclusion. Okay, so here I toss 3 coins together. So total number of outcomes is what? Total number of outcomes is equal to 2 to the power 3, that is equal to 8. Okay, and possible outcomes are head, 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 tail, 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 head, tail, 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 head, 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 tail, tail, head, 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 tail, head, and tail, tail, tail. Okay, so now probability of getting no head, this is actually equal to 1 by 8, since probability of getting no head, there only one possibility, that is t. Okay, and here total number of outcome is 8. Okay, so therefore probability of getting no head, this is equal to 1 by 8. Hence the given conclusion is wrong, because the probability of no head is 1 by 8, not 1 by 4. Okay, that is why this conclusion is wrong. Okay, so now let us move to next problem. So in next problem, here we have, if you toss a coin 6 times and it comes down heads on each occasion, can you say that the probability of getting a head is 1? Okay, so let us see and give reasons. So no, if let you toss a coin, okay, so then we get head or tail, both are equally likely events, so probability is 1 by 2. And if we toss a coin 6 times, then probability will be same in each case, so the probability of getting a head is not 1. Okay, so the probability of getting a head is not 1, so therefore we cannot say that probability of getting a head is 1. So this is not correct. So now let us move to next problem. So in next problem, here we have Susma tosses a coin 3 times and gets tail each time. Okay, do you think that the outcome of next toss will be a tail? Okay, give reasons. So let us check and let us give justification. So the outcome of next toss may or may not be tail, because when tossing a coin we get head or tail, so both are equally likely events. Okay, so the given statement, Susoma tosses a coin 3 times and gets tail each time. We cannot think that the outcome of next toss will be a tail. Okay, so this is not correct. So now let us move to next problem. So in next problem, here, if I toss a coin 3 times and get head each time, okay, should I expect a tail to have a higher chance in the fourth toss? Okay, and give reason in support of your answer. Okay, so let us give reason in support our answer. So our answer is no. No, I should not expect a tail to have a higher chance in the fourth toss. Let we toss a coin, so then we get head or tail. Both are equally likely events. Okay, that is probability of each event is 1 by 2. So no question of expecting a tail to have a higher chance in fourth toss. Okay, so if I toss a coin 3 times and get head each time, then I should not expect a tail to have a higher chance in the fourth toss. Okay, so now let us move to next problem. So in next problem, here we have a bag contains sleeves number from 1 to 100. Okay, if Fatima chooses a sleeve at random from the bag, it will either be an odd number or an even number. Since this situation has only two possible outcomes, so the probability of each is 1 by 2. Okay, and justify your answer. So let us justify our answer. So let us see the answer first of all. So we know that between 1 to 100, half numbers are even and half numbers are odd. Okay, that is 50 numbers 2, 4, 6, 8 up to 100, they are even, and 50 numbers 1, 3, 5, 7 .97, 99, they are all odd numbers. Okay, so there are 50 numbers, they are even, and 50 numbers are odd. So both events are equally likely. So probability of getting even number, this is equal to 50 by 100, that is equal to 1 by 2. Okay, and probability of getting what number, this is equal to 50 by 100, and this is equal to also 1 by 2. Hence the probability of each is 1 by 2. Okay, so the given statement, in this situation has only two possible outcomes, so the probability of each is 1 by 2. Okay, this is a correct statement. And now let us solve short answer type questions. Okay, so in this section we have to find the mean of the distribution in first question. So let us find the mean of the distribution. So we have given this table. Okay, so by using this table we need to find mean of the distribution. So we first find the class mark xi of each class and then proceed as follows. So for this class 1 to 3, class mark is 2 and frequency is 9, and then fi xi, this is equal to 18. And for class 3 to 5, here class mark is 4, okay, and frequency is 22, then fi xi, this is equal to 88. And then for this class 5 to 7, here class mark is 6 and frequency is 27, then fi xi is equal to 162. Okay, and for class 7 to 10, here class mark is 8.5 and frequency is 17, then fi xi, this is equal to 144.5. Okay, so now if we add these values, then we'll get summation fi, this is equal to 75. Okay, and if we add fi xi, then we'll get summation fi xi, this is equal to 412.5. Okay, so summation fi, this is equal to 75, and summation fi xi, this is equal to 412.5. Okay, so now we know the formula for finding mean. Okay, so mean x bar, this is equal to summation fi xi divided by summation fi. Okay, and this is equal to 412.5 divided by 75, and this is equal to 5.5. Hence mean of the given distribution is 5.5. Okay, so therefore the answer is the mean of the given data or given distribution is 5.5. Now let us move to next problem. So in next problem, here we have to calculate the mean of the scores of 20 students in a mathematics test. Okay, so we have given this distribution table and we need to find the mean of the scores of 20 students. Okay, so let us find. So here let us see the answer. So first find the class mark xi of each class and then proceed as follows. So here for this class 10 to 20, class mark is 15, frequency is 2, and fi times xi, this is equal to 30. And for this class 20 to 30, here class mark xi is 25, frequency fi is equal to 4, and then fi xi this is equal to 100. Okay, and for this class 30 to 40, here class mark xi is 35, frequency fi is 7, and fi xi this is equal to 245. And for this class 40 to 50, here class mark xi is 45, frequency fi is 6, and then fi xi this is equal to 270. Okay, and for this class mark xi is 55, frequency fi is 1, and then fi xi is equal to 55. Okay, now if we add these values, then we get summation fi this is equal to 20, and if we add these values, then we'll get summation fi xi this is equal to 700. Okay, therefore mean x bar this is equal to summation fi xi divided by summation fi, that is equal to 700 divided by 20, and this is equal to 35. Okay, hence the mean of scores of 20 students in mathematics test is 35. Okay, and this is the final answer. Now we need to calculate the mean of the following data. Okay, so let us find the mean of the following data. So here, since given data is not continuous, so we subtract 0.5 from the lower limit and add 0.5 in the upper limit of each class. Okay, so now first find the class mark xi of each class, and then proceed as follows. So here class for class 3.5 to 7.5, class mark xi is 5.5, frequency fi is 5, and then fi times xi this is equal to 27.5. Okay, and for this class 7.5 to 11.5, here class mark xi is 9.5, frequency fi this is equal to 4, and then fi xi is equal to 38. Okay, and for this class 11.5 to 15.5, class mark xi is 13.5, frequency fi is 9, and fi xi is equal to 121.5. Okay, and for this class 15.5 to 19.5, the class mark is 70.5, frequency fi is 10, and fi xi this is equal to 175. Okay, so now if we add such frequencies, then we get summation fi this is equal to 28, and summation fi xi this is equal to 362. Okay, so summation fi xi this is equal to 362, and therefore mean x bar this is equal to summation fi xi divided by summation fi, and this is equal to 362 divided by 28, and this is equal to 12.93. Hence the mean of the given data is 12.93. Okay, so now let us move to next problem. So in next problem, here we have the following table gives the number of pages written by Sarika for completing her own book for 30 days. Okay, so here in this row we have number of pages written per day, and in this row we have number of days. Okay, so we need to find the mean number of pages written per day. Okay, so let us find. So let us see the answer. Since first of all we need to find the class mark. Okay, so calculated class mark and fi xi. So here class mark 15.5 to 18.5 class. So then mid value is 17, number of days is 1, and fi xi is 17, and similar you will get these values. So here number of days, sum of number of days this is equal to summation fi this is equal to 30, and summation fi xi this is equal to 780. Okay, and since given data is not continuous, so we actually here could subtracted 0.5 from the lower limit and add 0.5 on the added 0.5 in the upper limit of each class. Then we know the formula for mean, that is summation fi xi divided by summation fi. Okay, and here summation fi xi is equal to 780, and summation fi this is equal to 300. So mean x bar this is equal to 780 divided by 30, that is equal to 26. Hence the mean of the pages written per day is 26. And then let us move to next problem. So in next problem, here the daily income of a sample of 50 employees are tabulated as follows. Okay, so we have find the mean daily income of employees. So here find the mean daily income of the employees. Okay, so since given data is not continuous, so we subtract 0.5 from the lower limit and add 0.5 in the upper limit of each class. So now we first find the class mark xi of each class and then proceed as follows. So and for this class, here class mark is 100.5, number of employees is 14, and ui is xi minus a divided by age, that is equal to minus 1 here, and a5 ui this is equal to minus 14. Okay, and for this class class mark is 300.5, and we here assume a is equal to 300.5, and age here assume mean. Okay, and number of employees a5 is 15 and ui is 0 and a5 ui is 0. Okay, and for this class class mark 500.5 and number of employees 14, ui is 1 and a5 ui is 14. And for this class mark is 700.5, number of employees 7 and ui is 2 and then a5 ui is 14. So n, capital N, that is equal to summation a5, this is equal to 50, and summation a5 ui this is equal to 14. Okay, so here since assuming a is equal to 300.5, class width, that means length of the class is h is equal to 200 and total observation n is equal to 50. So now by step division method, mean is equal to a plus h times 1 by n summation a5 ui I equal to 1 to 5. Okay, so this is equal to 300.5 plus 200 times 1 by 50 times 14, and this is equal to 300.5 plus 56, and this is equal to 356.5. Okay, so the mean by using step division method is here 356.5. And now let us move to next problem. So in next problem, an aircraft has 120 passenger seats. The number of seats occupied during 100 flights is given in the following table. Okay, so we need to determine the mean number of seats occupied over the flights. Okay, so let us find the mean number of seats occupied over the flights. So we first find the class mark xi of each class and then proceed as follows. So we can make this table. So here for number of seats in this given in this column, here we get given class of marks, and here we get frequency, here deviation di, and here fi di. So for this class mark is 102, frequency is 15, deviation di is equal to minus 8, and fi di is equal to 120. And for this class mark is 106, frequency fi is 20 and di is minus 4, and fi di is equal to minus 80. And for this class class mark is 110, and here assuming a is equal to 110. Okay, frequency fi is 32, di is 0, and then fi di is 0. And for this class for the class mark is 114, frequency fi is 18 and di is 4, then fi di is 72. Okay, and for this class 116 to 120, here class mark is 118 and frequency fi is 15 and deviation di is 8, and then fi di is 120. Okay, and here the sum of frequencies, that is capital N, this is equal to summation fi, and this is equal to 100, and summation fi di this is equal to minus 8. Okay, so here assuming a is equal to 110 and class width h is equal to 4 and total observations n is equal to 100. So by assume mean method, here mean x bar this is equal to a plus summation fi di divided by summation fi. Okay, and this is equal to 110 plus minus 8 by 100, that is equal to 110 minus 0.08, and this is equal to 109.92. Okay, so the mean x bar this is equal to 109.92. And now let us move to next problem. So in next problem, the weights in kg of 50 wrestlers are recorded in the following table. Okay, so we need to find the mean weights of the wrestlers. So let us find. So here we first find the class mark xi of each class and then proceed as follows. So here for this class 100 to 110, the number of wrestlers 4, class mark xi is 105, di is minus 20, and then fi di is equal to minus 80. Okay, and for this class 110 to 120, number of wrestlers for 14, class mark xi is 115, di is minus 10, and then fi di is minus 140. And for this class number of wrestlers 21 and class marks xi is 1 to 5 and di is 0, fi di is 0. And for this class, number of wrestlers fi is 8, xi is 135, di is 10 and fi di is 80. And for this class, number of wrestlers 3, class mark 145, the di is 20 and fi di is 60. So now n, this is equal to summation a5 and this is equal to here 50, and summation a5 di, this is equal to minus 80, and here assuming a is equal to 125 and class width h is equal to 10 and total observation n is equal to 50. So now by assume mean method, mean x bar, this is equal to a plus summation a5 di by summation fi, and this is equal to 125 plus minus 80 by 50, and this is equal to 125 minus 1.6, and this is equal to 123.4 kg. Okay, so the so therefore mean weight of the wrestlers is equal to 123.4 kg. Okay, so this is all about this lecture. I stop here this lecture. Thank you very much to all of you.